I'm now going to show you the VPIS sensor. So the VPIS sensor consists of a red and a black probe, test leads. The other end of that is a LEMO connector. So when we plug the LEMO connector into our +2, you'll notice that the top screen there turns to VPIS as opposed to it was TEV. And then what we do is we get our probes that are here. You can put normal different connectors and all that type of stuff on, but we would plug these into VPIS ports or your VDS ports on your switchboards, ring main units, whatever you have on your network to pick up PD signals. So the screens that we have is, I go to VPIS, we've got a basic measurement screen that's going to give you, VPIS gets measured in millivolts. So here we're measuring nothing, so it's 20 millivolts, which is very low. Pulse per cycle count, a severity count, and it gives you a running screen of what your last measurement was. The most useful one is this one here, the phase plot screen. We click in that. It gives us a sine wave. It gives us a phase plot, so we can zoom in and see the phase plot. Now, when we plug these ports into the VPIS, it will automatically get its phase lock from the VPIS ports. When it does that, it knows exactly what the phasing is, and when you capture PD, it knows exactly where the PD is with reference to that phasing. It's the only one out of all the modes that's able to do that because it's the only one that's able to physically connect to the network. When I go through my settings, it's very similar to all the others. We can listen to ultrasonics or we can listen to VPIS. You can mute it, you can turn your volume up and down. Again, we can get a phase lock from either the lights, the VPIS itself, the wireless or the manual. It will automatically change to VPIS when you plug the VPIS sensor in. So that's the best way to do it in this mode. And again, you've got your persistence mode that will make your phase plot automatically reset itself. You can see it's resetting itself there over and over and over. But I like to keep that one set to infinity just for my preferences. Okay, so that's all the menus for that one. You've got a histogram, same as the others, where you can count up the PD pulses relative to the decibel level. And you've got your waveforms. So your waveforms for your VPIS will, again, you can look for sharpness in the peaks and that type of thing to figure out if it's real PD or if it's some sort of noise when it's a lot slower and all that type of stuff. And that is VPIS. Now I'll show you how to use the wireless phase reference. So this is a wireless phase reference unit. It's a very handy tool for giving your UltraTEV Plus² a phase lock remotely. It does it via Wi-Fi. Basically, you set this one up to get a phase lock, and then you leave it there for while you're doing all your tests, and it sends the phase lock via Wi-Fi so that you don't have to waste time trying to get a phase lock, and you're always capturing the most accurate data that you can, which is definitely what you want when you're doing PD testing. So the way to lock it on is just say you go to ultrasonic mode, then we go to the menu, we go into any of these screens. It doesn't matter what mode you're in. You can just go straight to the power screen, click on wireless, and it'll say, do you want to connect to a wireless phase reference? You hit yes. What we need to do then is turn this instrument on. Hotspot starts up inside the +2, and then it says press the Wi-Fi button on your wireless phase reference. So the Wi-Fi button is this one. We press that button. This does a bit of thinking. Eventually this light here will go green. And this will give us some words on the screen that say successfully connected to the wireless phase reference. Okay, so now what's happening is you'll see that I have a phase lock which says 50 Hertz, the number's white, so I know I have a phase lock. The default setting on this is, if you look at all these words here, it says photo, power, Rogowski, and E-field. The default setting is photo, and that means that this little sensor here is looking at the lights. So if I cover this up, the number on there will go red because it's not hooked onto the lights, and you can see that that's what's happened. If I take my hand off that, this number will go white because that can see the lights. So that's one of the easiest ways. So if you're in a substation, just put that thing near the lights and hook them up together, and then you're good to go for the whole survey. No matter if you put this into the shadows, you'll always have a good phase lock. Now the next way is power. So what we have here is a 240 volt transformer. It will go through, well, it's a step-down transformer really. It's 240 volts on one side and another voltage on the other. I'm not sure what it is, but it runs at 50 Hertz. So we plug this into the bottom. This automatically changes to power because it knows it's plugged in. While that's plugged in, it will charge your battery, and it gives a phase lock to the instrument. Just to prove that's working to you, I'll pull that out of the 240. That loses its lock, that stops charging, and this loses its lock here. So that's how that one works. That's a very good way of doing it. Next one is Rogowski coil. So if I change my setting to Rogowski, I then have this Rogowski coil. This is a Rogowski coil. What you do with that is you place that around a conductor. The best one that you can find is a single phase unscreened cable with current flowing. That's the best way. And it doesn't have to be HV, it can be LV. Quite often it works better on LV because you've got some more current on LV and it's more accessible. And then what you'll do is you'll plug the end of that into this here. So my Rogowski coil is plugged in. I'll then go out into the field, plug this around a conductor, and that will send a phase lock to here. I can't find anywhere in this room that I'm in to give you a good phase lock, but it does work. And then the last one is E-field. So if I click this button here again, it changes it over to E-field. And then what it does is it tries to find 50 hertz in the air and send it to this instrument. And right now it is doing that. And that's because there is some 240 volt cables around here and they have some AC running. So this here is a 240 volt cable. If I put that on the cable, it'll pick up the 50 hertz and it has sent it to the instrument. So one of the easiest things you can do in the sub is just change this straight to E-field and then put this instrument near some cables and see if you get it, and then just leave it there for the rest of the your survey. So the reason you would do this is so that your phase plot, which is the picture here, looks perfect every single time, so that your +2 samples the PD data at the exact same rate that your frequency is pumping it out. Your frequency on the network everywhere is always changing. Like if you look at this here, it says 49.98. It'll say 9.7 now. It'll say 9.8 now. And that slight change, 9.9 now, that slight change is enough to upset your phase plot when you're recording it over the 10-second recording. So it's worth getting it so that you get the most accurate data that you can. Now I'm going to teach you how to use the UltraTEV Plus² Locator Probe. So this is the Locator Probe here, and you see how these two here are blanked out. It says Locator, Locator Advanced, and both of them you can't click on because they're not enabled yet. Once we plug this in, those two will become enabled. As you can see, that happens just now. The light will come on this, as you can see, and the instrument will tell you that it needs to be calibrated when you go into one of those menus. So when I click on Locator, it says, please hold the TEV plates of the UltraTEV Plus² and the Locator Probe together in order to calibrate. Press OK when both instruments are in this position. So what you then do is you hold these two together, like so, and then hit this OK button. It says calibration's in service, do not move, and then it says calibration complete. And what it's basically doing is it's pumping out a bit of TEV, receiving it in the other sensor, and then it measures how long this cable is, because that's of utmost importance to figure out how far away the PD signals are being captured between the sensors. Okay, once we're ready, now what you'll see is a whole bunch of numbers and colors jumping around on the screen, but basically both the sensors are actively measuring for TEV signals, and this is in automatic mode, so it's always measuring its limits of what it's actually measuring is the best way to say. All right, now what I have here is a test source. This is pumping out some PD. So what I can do is if I put my red probe on the test source and I put my blue probe on something else, you'll see that it says triggered on the red probe. It's also triggered on the blue probe, but the red one has seen it first. So it's telling me which probe saw what first. And then we swap it over. So if I swap it over, we can see here that they're both triggering, but the blue probe has seen it first. So that means that wherever I've put this probe has seen the PD signals before it's seen this probe. So you can figure out where PD signals are coming from within your switchboards, or if they're going up and down cables and all that type of stuff. If I go to manual trigger, just while we're on this screen, and I hit level on the blue, what that's doing is it's measuring the TEV signal coming in on the blue probe, which is 52. If I hit level on the red, this red probe is currently measuring 41 because it's a bit more distance away from the test source. That's another good setting to play with in the field to get to the top trigger levels, as opposed to when you're in auto mode, it will do very low trigger levels and you may be able to figure out where the PD is coming from that way. Depends on how much noise is around and all that type of thing that influences it. Now the other screen is Locator Advanced mode. We click this one and we can see that there's a bunch of activity on the screen here that's closer to the blue side of the screen. If I move this away from the test source and I move the red towards the test source, you'll see on my screen that all the PD activity has moved across to the red side of the screen. So that's how it works. You can see if you've got multiple PD sources and you can see which probe is closer to the PD. Again, if I go to manual trigger, hit level, that's going to level out the red probe. If I hit the blue one, it'll level out the blue probe. And I can see that most of my activity is closer to the red probe. And then if I swap them over, whenever you move your sensors, I highly recommend you hit level and level again. Otherwise, you're going to be still stuck on the last trigger levels, which won't be correct for where your probes are. And you can see now that all the PD signals are closer to the blue side. So that is how the locator works.